What I want to do, no, I said I used to watch it. I want to talk about the idea of similar triangles today. It ties in nicely to grade. It's actually, I was thinking about it the other day, and it's a brand new topic. I've never done this in 105 before, but it seems a very logical place to go from grade before talking about the rates of change of linear modeling. So I was thinking, this is kind of cool, and this is something that actually is very, very useful. You'll see one application of it today. You've already seen a bunch of applications, but you didn't realize it. Well, more on that today. So, how many of you have heard the phrase similarity of polygons, or in particular, similar triangles before? Anybody ever heard this before? Similar triangles or similar polygons? Just show a hand. Well, they're both common words, right? But how about used together mathematics? Very common word. Very good, Ryan. Namaste. We couple 5 people have heard them, ish. Okay, maybe more than 5, maybe 6 or 7, but not many. The majority of you haven't. How many of you took geometry at some point in your academic careers? Okay, which means that it's been flushed from your memory. Because you did study similar triangles in geometry, it's just been so long ago that it's gone away, and that's totally fine. Which is unfortunate, because I think it's probably the most important topic in geometry. The most important. And I remember I rewrote the curriculum at my old school to emphasize it more. They were talking more about congruent triangle. Remember the word congruent from geometry? Congruent? Things that are exactly the same size and shape. Well, similar triangles are more general than congruent. So here's what similar triangles can look like. Well, you know what? Let's define it first. 2 triangles, or more, but we'll do 2. 2 triangles are similar. And this is what makes triangles similar. If each angle, let's use the word angle, if each angle in one of them equals an angle in the other, that's what makes triangles similar. If you have 2 triangles, and you can find an angle in one of them and say, okay, that one's 23 degrees, that one over there is 23 degrees. That one up there, that's 57 degrees, that one down there is 57 degrees. Yeah, sorry about the pen. I left my big stack of pens in my office, I hope. I had to borrow them, this one kind of sucks. Oh, good, maybe we'll switch over. Yeah, go ahead, thank you. Great, like I'm sponsored. So, this is the literal definition of similar triangles. So what I want to do is I want to look at a few cases. I want to look at a few cases of them. First, a very basic case, which I think we have enough sun to use today. I think, maybe. There's 3 cases I want to look at in particular today. We might have enough. Think that'll throw a shadow? You guess enough sun to throw a shadow? What do you guys think? Yeah. If it'll throw a shadow, we can do this case, I think. Yeah, I think it will too. So, the first case, I'm going to call this the shadow case, if you will. We'll put that over here. Case number 1, that's much better. The shadow case. And I'm only going to call it the shadow case. You'll see why it's called that when we go outside. Nobody has to call it that right now, so we'll call it case number 1. Looks like this. Suppose you've got, and I'm going to make these right triangles. Remember what a right triangle is? A triangle that has a 90-degree angle. I like utilizing those because generally we want to measure things outside that rise up from the ground perpendicularly, like a building or a mountain or a tree. In our case today, a tree. So things that grow, if you will, vertically out of the ground. Fair enough? Makes sense? So we're going to stick a right angle there. Now I can also tight. I'm going to try to make these look without a grid on the board. It's a little tricky. So, let's make sure we can see that okay. That's not bad.